What is overtravel on a butterfly gas valve? So this is a SCC butterfly gas valve, and it has an overtravel kit installed on it. So this overtravel kit is an arm accessory that connects to the gas valve that's behind this indicator plate, and it allows the gas valve to move without the movement of the actual blade, as we can see here on this damper. So the blade is 100% closed in this position, so we are stopping gas flow, and it is 100% open in this position, so we are allowing 100% of gas flow. So what the overtravel does and why we would use it is we have low fire and high fire, and we want repeatable positions for both of those, especially low fire. So with linkage, you have hysteresis, and that is all the movement and play that comes with the linkage. And even if you have all brand new parts, they all have a little bit of slop. And how you can see that is if you were to set combustion from low fire to high fire for 10 points, and then do the exact same points, high fire to low fire, your combustion would be slightly different, because driving up your air damper and gas valve one way, even with parallel positioning, it will be different than driving down from high fire to low fire. So how do we set it? So let's say our light off position is going to be 15 degrees. So we have this stop right here that is connected to this, and we have these adjustable set screws. So we're going to screw this down so that it's going to hit the stop when our valve is at 15 degrees. And this would be determined by your combustion, but in this case, on this boiler and burner linkage trainer, it is determined by exact indicator that comes with the trainer. All right, so we're at 15 degrees. So let's go through the sequence of operations. So we're going to go into purge, and we're going to adjust this accordingly, but we'll go into purge. It's going to hit our high fire position, and then we're going to come down, and the fan is ramping down, Boom. This is when we're going to hit our low fire position and our light off position. So our mod motor is going to trigger the flame safeguard to probably go to pilot. And we're always going to go to main flame. We'll have pilot and main flame at the 15 degree mark. If we don't have that, and we were to just back this off a little bit, our low fire position would change, and you can see just a little bit of movement here can really affect the degree position. And on low fire, especially on smaller boilers, anything under say 100 horsepower, it's very sensitive since you have such small gas flow to start with. And just moving the gas valve just that little bit, you can see 2 or 3 degrees makes a drastic difference on your low fire light off, which is your combustion. So setting the stop allows us to always hit 15 degrees or wherever we set it. So let's set that back to 15. And once again, this would be determined by combustion. This is going to be different on every single boiler. There's nothing magic about the 15 degrees in this case. So we would adjust the movement of this arm to hit this and then move probably that far. So we want to put pressure on it, but we don't want to go all the way down, especially not to the end. You don't want to be jamming up your linkage. We just want to put pressure on it. And that allows us to get the overtravel. Not enough pressure, and we may not hit that 15 degrees all the time. We might just gently tap against it, but too much, we're going to go all the way. And then especially if you're going to go all the way here, and when you're actually going to start driving up, you're not going to have gas response, and your air is going to respond quicker than your gas, because as it's driving up, your gas isn't moving. And if you're trying to do that and you're trying to slow down your gas, don't slow down your gas in your over travel. You need to do something else. Either speed up your air, but you're only supposed to use this in order to get a repeatable position for low fire and high fire. So just put a little bit of pressure on it, and when you go the other way, and you won't know this till you're in high fire, but when you go into high fire, say 80 degrees, and we would adjust this to hit, the high fire mark, then we would screw this in so that we would hit 80 and we would hit 15 repeatedly. In between for linkage doesn't really matter too much as far as accuracy, but being accurate on our high fire input and then being accurate on our low fire input, because our light off is so critical, is why these over travel kits and arms are very useful to put on gas valves. Once again, this one's from SCC. This is a very popular gas valve. This is a custom indicator plate and a custom indicator. So this is what it's going to look like if you actually set it up correctly. So in this scenario, low fire position is going to be 15 degrees. So I'm going to drive, we're driving the motor down. So say the boiler is lighting off from high fire to low fire. And as you can see, we're coming down. We're going to hit the stop here. This stops at 15, but this keeps moving. And that allows us to have a repeatable low fire position without having to have the play of linkage. So now this puts pressure. There's pressure against this. So this puts pressure against it. So it's way more repeatable than having it without the stop. Let's do a scenario without the stop now. I've loosened the set screw, and we originally were at 15. We're driving down to low fire. And I'll just show you how much over travel we had. So without the set screw and this over travel, if this was just a normal linkage arm on the gas valve, we would have driven 5 extra degrees. So the movement on this between hitting the end stop here at 15 degrees and keep going down is an extra 5 degrees. That can be shortened, but in this case, instead of trying to exactly hit 15 and adjusting this and it's very easy to set this end stop at 15 and then have it put pressure and a little bit of over travel. In this case, it was about 5 degrees of over travel, but you wouldn't see that because that's all taken up from this arm moving and the inside spring-loaded bearings taking all that up. So you can see even just the slot in just this one connection. And this is tight. This bolt is tight, but it's the slot between the bolt and the eye of this connection. So all the way down is 9 degrees, and all the way up is about 10.5 degrees. So about 1.5 degrees of slop that you can, and that changes and multiplies through the whole linkage system. And this is only one connection. So to the motor, we have, in this case, 1, 2, 3, 4, 5, 6, 7, 8, like 9 connections. So imagine this over 9. But if you were to ever, on your next boiler that you're running, you will see if you were to go like this on low fire or this on low fire, your analyzer is going to dramatically change if it's a small enough boiler. And that is how important this linkage stop is. So to recap, this is what a normal gas valve would look like. This is the normal plate. As you can see, the indicator is on it, but is not super accurate. And this arm gets bolted to this, so it has positive attachment. So you have gas flow. In this case, you have 90 degrees. And then you would have 0 degrees. So this arm is optional. There's other arms for these gas valves, but this is an over travel arm. So with an over travel arm, it's not required, but highly recommended. And you set the low for low fire, and you set the high for high fire, and it gives you a repeatable position. And that's very important because linkage is an imperfect science, and there's a lot of hysteresis in it, and having repeatable positions on low fire and high fire helped set up the boiler correctly.